Hello, friends, and welcome to Mission 5, Lesson 2, where our student objective is to decompose fractions as a sum of unit fractions using tape diagrams. Does that sound familiar? Well, it should, because that was also the objective for yesterday's lesson. So, same objective today, and we're looking at fractions and tape diagrams. I'm going to go over the Tower of Power for today's lesson with you, so let's get to it. Let's take a look. Alrighty, so here we are on the Tower of Power for lesson 2. And it tells us to start off with, it wants us to model 4/5. So partition the tape diagram to show fifths. So partition means break it up into fifths. So if it's fifths, how many total pieces do I need? Well, I need 5 total pieces. Again, I look at this fraction, numerator is the top number, denominator is the bottom number. The denominator, the bottom number, tells me how many pieces total I have. So in this case, 5. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay? I just divided up into fifths. Excellent. I feel so smart. Okay, now it wants us to shade the tape diagram to show 4/5. Well, again, 4/5, the numerator tells us how many are shaded. So it's 4/5. I'm going to shade 4 out of the 5. 1, 2, 3, and 4. 4/5. Good work. Thanks, me. And now it's asking us, okay, it says show how you can add unit fractions to make 4/5. So what I can do there, it just wants me to show that what plus what plus what plus what equals 4/5. It just wants me to break it down each piece. And what is each one of those pieces worth? 1/5. So that's worth 1/5. This is 1/5. This is 1/5. And this last one is 1/5. Each piece is 1/5. And 4/5 equals 1/5 plus 1/5 plus 1/5 plus 1/5. Because that's 4 of them. Excellent. Okay. And now it wants me to write an equation to show how 4/5 is decomposed in the tape diagram. So now it just wants me to say, okay, here notice they use different brackets. They bracketed 2 of them at a time. So 2/5 together, 2/5 together. So they put a 1/5 and a 1/5 together. So they put a 1/5 and a 1/5 together. What does that equal? Well, 1/5 plus 1/5 is, right here, 2/5. And this is the same thing, 2/5. Excellent. Okay, keep climbing. I'm going to do my best. Okay, now we want to write an addition sentence to record the decomposition of 4/8 into 2 parts. So now we have 4/8. So that tells me if it's eighths, I need to partition it into eighths. So that is 8 pieces. 1, so 3, 4, 5, 6, 7, 8. Again, great job, me. Now shade the tape diagram to show 4/8. So how many need to be shaded? Well, it's 4/8. 1, 2, 3, 4. 4/8. You got it. I do got it. And now we're going to show how you can add unit fractions to make 4/8. So what it wants me to do here is just what is each piece worth? Well, 4/8 equals 1/8 plus 1/8 plus 1/8 plus 1/8. And that's what we're going to do. So that sum of unit fractions means we're just breaking it down piece by piece. Again, sum, as a reminder, means the answer to an addition, right? So we're adding. Good work. Okay. And now they bracketed it, and it says write an equation to show how 4/8 is decomposed in the tape diagram. So now you notice they just put 2 of them together, and so they have a 2/8 and another 2/8. So it just wants us to say 2/8 plus 2/8 also equals 4/8. Nice. Okay. And then it's asked which tape diagram shows another way to decompose 4/8 into 2 parts. Okay. Well, this first one, it's 1/8 and 2/8, but that's 1 and 2 together is 3/8, so that's not 4/8. This one has 1/8 and 3/8, and 1 plus 3 is 4. So it's going to be the second one. Okay. And now it wants us to write an equation to show how 4/8 is decomposed in the tape diagram below. So it wants us to just write the equation for here. So they notice they have 1/8, so that's going to be my first one. And then it has 3/8 together. So 4/8 equals 1/8 plus 3/8. Nice. Okay. Keep climbing. I'm trying my best, but my hands are getting tired. My legs are getting tired. My brain's getting tired, but I can do this. I can do this. We're going to decompose 6/5 into 2 parts now. 6/5 into 2 parts. So it says, how many holes do you need to represent 6/5? Show the holes on the tape diagram. So this is where it gets a little tricky. 6/5 is more than 1 hole. And I know this because the 6 is greater than the 5. The numerator is greater than the denominator. So that tells me this is going to actually be, boom, 2 holes. I need at least 2. Okay. Excellent. And now it wants me to partition the tape diagram to show fifths. So I need to make each one of these as fifths. So notice it does it to both here, which is fine. Okay, so I have fifths now. 1, 2, 3, 4, 5. So I have fifths. Okay. And each of these tape diagrams is representing 1 hole. Now I need to shade the tape diagram to show 6/5. Well, 6/5, how many do I need to shade? 6. 1, 2, 3, 4, 5, 6. And this is why I needed more than 1. And this is why I needed more than 1 hole. You got it. I sure do. And then now it asks which tape diagram shows one way to decompose 6/5 into 2 parts. Well, I'm looking for 6/5. This is 5/5 and 1/5. 5 plus 1 is 6. That'll work. This one is 5/5 and 2/5. Well, 5 and 2 is 7. So I know it's this first one. You got it. Okay, hopefully I'm towards the top. Write an equation to show how 6/5 is decomposed in the tape diagram. So here, notice the brackets. It has 5/5 under one bracket, and then it has 1/5 in a bracket. So because it had 5/5 and it had 1/5. So that's what I'm just going to copy that here. 5/5, 1/5. Great job. And I did it. I earned it. So notice it's similar to what we did on the previous lesson. We're just expanding it and taking it a little further. Okay. Good luck on your math adventures. You're going to love it.